Right, so this is a bit more technical and specific. It shouldn't be difficult at all, but so don't get worried if you get a bit, you know, there's a bit of terminology and we're working with a database. So if you're not used to that, it might look more complicated than it is. And because we don't have a lot of time, while I'm trying to run it sort of interactively, you might not have enough time to follow up. But I put this training online on the NCI as a training site of a website. I don't know if any of you had ever bumped into this. You might have if you tried to set up a remote desktop. So you had to actually log in. I mean, you can go to the home page, but you wouldn't be able to do anything. And then you can see here all the different courses they give. So the first one they put is how to set up the remote desktop. Does anyone know what the remote desktop or VDI is? Does anyone know? Listening? So it's basically, it's a remote desktop. So it's something you can use to set up an interactive session, and you don't quite use raging. Basically, you use like a small desktop that don't have access to all the G data or most of the G data space, so you can have access to the data and work remotely. I have set it up, so we're going to see exactly what it is. So this was the first course they done, and then they had a few more things, like they've been delivering a summer school, which I believe at a data workshop. So I think in this data workshop, for example, there was an introduction to some of the things they have, like the NCI data catalog, and also goes into some example in IPython, and I don't know if they use also, maybe there's some stuff on MATLAB as well. And they talk, for example, here about OpenDAP for the people who were listening before, an example on how to using it. So it, you know, just feel free to go in there. Anyone who's got an account with NCI can go in here and use one of these courses. So what we did at some stage, under this research data, with the help of Claire Tran from NCI, we decided to add a CIMIP online course, which was partially because if you ever use CIMIP, you know you're going to have lots of issues. And we always have to answer the same questions about why something would have been in a place and in another, how often things gets updated, and just generally, you know, like all the issue we had, like the big outage we had last year. So this is advice for anyone who's trying to use CIMIP. I don't know, if you've already been using it for a while, you might not need to go through this, but we'll ask for anyone who wants help and starting to use CIMIP to go through this before. And it goes from creating an account, how the data is organized on raging, and it's officially organized on the different various nodes and things. Anything you might need to know about CIMIP, and we'll have more things while we're going on. And also talks a little bit about Confluence, actually, which probably you wouldn't know either, I wonder. So Confluence is again, you have to log in. It's a sort of, it looks a bit like a wiki in a way. NCI has set it up. Some of his help desk go through it. So not our climate help yet, but the main help desk actually, if you go through the web interface and you start typing in your question, it might comes out with links to parts of these Confluences where they're going to put all the information and stuff. And there's a particular section which is the CIMIP community on, where there's all again, lots of information about CMIP, announcement, known issues that we found where you can go there and you can log in and tell us, you know, if you have some issues and stuff. There's some blogs and things we've been doing. We've been having for about a year regular meetings. We had a technical stuff at NCI, at the Zero Bureau, which is about CMIP, also about other data sets and things. And we put, for example, all our meeting, you know, notes in here. So we use it in various ways. There's frequently asked questions. There's information about NCI, ESGF node, and all sorts of things. Right, so that's just for you to know. This is not about this. So you can find all that sort of information on the training. Sorry, Zoom is stopping me from reaching my bar. Yeah, get away. Oh no. But see, so we're trying to collect all this information. We're just really releasing now, so there might be things to fix. And we inserted this ARCCSSive Python module in here. So, oh, sorry, I'm not sharing the right thing. Why did it stop share? Screen. Okay, can you see now? So you can get here, and you can go through anything we're going to touch today, and actually with some extra material as well. Also, basically the way I structure this, I created a Python notebook. I put it together with a module in the module GitHub. Anyone can download it and use that to run through. So if you don't remember, you can't follow completely things today, it doesn't really matter. You can go through back later. So just explaining better what it ARCCSSive is. So it's basically it's just a Python module that we built based on actually I should go back. We built a simified database because we were a bit exasperating to just have to use the file system. For me, when I had to download data for people, it's really important to be able to know straight on if that data has already been downloaded somewhere else, we have an older version or whatever. And I was a bit sick to have always to work out this information from what we have, just by looking at directories and stuff. And even if I started before doing some script, which will do that for me. And then we thought, oh, it would be much more neat actually having a database, and then we can add some extra information and keep it there. So that's what we did, and we use SQLite, which is the most basic and simple thing that we could do on our own, and we could use them raging. Basically, it's so simple that it's really just a 1.2 gigabyte file, something like that, which you could download from raging yourself and use on your laptop or whatever. But we wanted then for people to be able to integrate the sort of information they can find on the database straight on when they're working with Python. So we created this module called ARCCSSive. And the aim was, as I say, was partially to give user extra information like versions or tracking ID without you having to necessarily open the files, and checksum without you having to recalculate them. Checksum are particularly important for us. It's just so we can compare what we get online and what we have on the system. But also correct information on version wherever we could, because some of the version are not stored neither in the file nor in the directory, because particularly for the published data. And then something, as I say, that you could use straight on in your session or eventually integrate into a script. So you don't have to repeat always the searches and things, but just get your script to do it for you. It's fully available on GitHub. We compile the latest stable version in Access module, so anyone can use it on Raging just by loading it from Access. But we also added to Conda distribution for people working on the VDI, which is a lot better to actually work interactively. So in case this, probably you wouldn't even know about this because it's fairly new. So now when you, for people who have been working on the remote desktop, there was this issue of having to sometimes to restore some of the things, and lots of people wanted to use Conda. And what Scott did was to create some Conda environment that are storing G-data. So it's not a problem for your own directory. You don't get it exploding by adding new bits and pieces. And you can load them. And there's different flavors offered, like an analysis free, analysis 2.7, Python free, Python 2.7. And then if you want additional modules and things, additional libraries, which are there, they'll get installed on your own directory. So this will know straight on, just using the normal Conda. Right, so we put the module, I'm showing you this because Scott, just before Easter, added the ARCCSSive latest module in analysis 2.7. So even if you're using on the VDI, you don't have to actually compile it or doing anything, which is fairly easy to install, but this makes it even easier. Sorry, again. Yeah. So at the end of this, you should know how to load the module, start a Simify database session, how to perform a very simple search, how to look at the result of the search, how to find the information. And then we look at some simple way to filter further your search result, and then how to go from actually searching to using the data. So where is the information that allows you then to open the files? And we look at a very simple example on how to integrate ARCCSSive in your code. And then I'll show you some custom script which are based on ARCCSSive and you can already use, like a search script and some stuff. Then in this training, we won't run through this, but there are some extra if you want to go through and be a little, if you find that's useful for you and you want to get the most out of it, you really have to use a little bit of SQL. To facilitate it also for ourselves, we know expert to SQL too. We use another module which is called SQL Alchemy, which makes it easier. But even better, if you never use SQL Alchemy, it could be a little bit confusing. So along the training, if you do the training online, there are some buttons you can click to add some extra information. And if you instead using the notebook, there is a separate notebook which show you, for example, the different how to do it, or and, or in, and all these kind of different operators in SQL Alchemy. So if I don't show you what the database look like, okay, that's not working, so we're gonna open this one. There's a page on Confluence about the database, which is the script with a full description. Now we're just gonna look for the diagram. You need to know, you don't need to remember this now, but you need to know a little bit on how we structure it. Otherwise, it won't make sense what we retrieve using the module. So this might be as well the most complicated thing. So we decided to have, basically we have 4 tables. The first and main table is called instances, and every instance is characterized by a particular MIP model, realm, a particular variable as well, an experiment obviously, and an ensemble. We added realm doesn't really matter a lot because it often is included in the MIP or in the combination of MIP variable if you want it. But we put it there for people who want to retrieve the DRS tree path. or we might need that in any case. But anything else, each instance is unique, so you can't have two instances. What is not unique is that you can have more than one version for a particular variable, particular model, particular experiment, and so on. So we have a different table version, which depends on the instances, and in that is where we put actually the path on the file system. So this path is where the file is stored, which is normally in an official TMP tree. This is not the DRS tree path, because that's just a link, but the actual, where the file actually is. And we added other information. Obviously, there is the version, which sometimes is not available, and you find NA. And then we add other information. There's something that we actually use to compare, like the dataset ID. That's an official ESGF field that come from the database. And we use that just to compare what's online and what we have here. Regardless, there might be different order, dataset ID might be the same. We got is latest. That's just it's either latest, it's either true or false, and it's not what's latest available on Raging, but actually means that that's the latest available on the ESGF. And check on will tell you that that's the date in which we check on that. So if we had other things, they'll tell you, other functions really, they'll tell you what's the latest available version on Raging, the local version, but we wanted to add something that labeled something as, okay, this as 2 months ago was the latest thing you want to have. So then you can decide if you want us to check for if there is something newer. Maybe if that was 2 years ago, it's never been checked, which is the case for lots of stuff. Because we fill in this just when we do a comparison with the online. Otherwise, it will take a very long time. To update means that there might be some issue with the files, if that's true. And then there is, every version's got its own files, and for the files we'll keep in the tracking ID. Then we have 2 different kinds of checks. Somebody wouldn't care about that, and obviously the file name. So to have a complete path to a file, you have to have that path in the file name, obviously. And then we added an extra table, which is warnings, which is also depends on the version. So if there is some issue, and I just started lately, we haven't had many, but we're going to do this soon. I'm going to go through all the CIMA5 errata. So if we find something on the official errata page, or someone has told us something, they eventually, hopefully in the next couple of weeks, they will all end up in that warning table. And you can also yourself signal something. So warning could be anything. It could be, you know, we can't download these anymore, we can't update it anymore, maybe some of the files are broken, you know, or this has been unpublished for whatever reason, or this is the official version, everything is fine with the files, but, you know, actually the values are all over the place. And the warnings again, so would be for one particular version, one particular variable, and whatever. We have a system. If you tell us, oh, all these models got some issue for this experiment, we can quickly, you know, create warnings for every single field. But that's the way we organize it. So you could have, you know, warning just for a particular variable rather than, you know, saying, oh, all this data set is to throw away. And in the warning, we write who's been adding it, and when it's been added, and normally added by is just actually the email of the person, because we can't write a real poem in there. So eventually, if you find, oh, this is really bad to calculate some whatever flux, and well, then you can contact this person and ask them why they think so, and what did they do, and what was the particular issue. We don't know if it's useful. I mean, it's up to you to tell us. We consulted obviously with some users and they thought it was interesting, but it doesn't become a bit more interactive, then there's not much point. So, sorry, now I get to change. Is there any question about the database actually before I go on? Because that's in a way is a tool in itself. And as I said, otherwise anything else might be a bit more unclear.
The path, is that always to the latest version? Or what if there are several versions?
Yeah, no, that's why the path is with the version, because you have a path for each version. So that's why we split it in this way. We've been thinking of doing a database which had just have the latest version and nothing else, but then we weren't sure because some people might have used a particular version already, or what can happen as well is that you might not have all the variables for that same version and things. So we just thought maybe it's better to be kind of complete, although and it might take a while. We're trying to come together with NCI and really delay the really bad version, incomplete and with mistakes and stuff, and do a cleaning. There's really no one who is in charge of that, so it's been a bit complicated. I can't just go there and do it myself, but we definitely talk about doing it, and then that should make it a little bit easier. Which is, we'll see how to work out what's the latest version, and you'll see that it doesn't give you one result. It can give you more than one, give you what in Python is called a listing pair. So, right, so I'm trying to run this from the VDI. So wouldn't want to waste too much time talking about the VDI, but if you have doubts and you want to know what it is and how to start it up, come and talk to me after. And basically, I started this IPython notebook, as I was saying, which is going to mimic what's in the training. So, as I say, it's in the access module. After I actually wrote that bit, I had to add this morning. We just added to this conda environment. So in this case, this is what you will do on Raging. Module use access module. You don't need to be in the access group to use these modules. They're available to everybody. And then module load Python lib ARCCSSive. Because we are using an NVIDIA instead, we're going to use these other public modules and load the conda environment, which actually I've done already, but just to go ahead. Then you add to tell, it might be different in the latest version, but just not to create confusion. You have to export the CMFI database location. This is where it is, and this is the way you do it. In reality, if you load the module, and potentially when we conda do, and I haven't tried that myself, you should actually do that for you. You should set up this environment variable. But if you start telling you, I can't find this database, then you know this is what you need to do. Which means also that you could use potentially a different database. In fact, we started one for GeoMeep as well. That's the other one, and we might eventually make this module not just about CMIP, but about other databases as well. So as you do in Python, from the module you can import just this CMIP file, which is what you do to open a connection to the database. So I don't want to overwhelm you with that. It's just a necessary step. So basically, what we're saving here in this DB is a session object, and this session is kind of a container which say, first of all, okay, I'm working with this database, and it manages all the communication between the database and your Python when you're working. And you wouldn't change the database, but if you were changing something in the database objects, then it will all be kept in this session. You can run, so every query go through this session, and we put some helper function to do some common operation, and maybe this is one of the one which could be useful. You can just run this models function, and what you get, it gives you all the models which are currently available in there. So you get this long list of models. You can do the same actually for experiments and MIPS and variables. I won't do variables because it'd be incredibly long. So, you start getting the, the potential value you'll have in this table. Is everything clear up to now? Yep, right. Then are we going to do a simple search? Again, we created a function which makes this a bit more straightforward. So again, you have to, it's a method of this DB, which is the session, and I'm saving it into result objects and like that. I mean, I'm just using a little bit of, it's talking about objects and method. Okay, with everybody? I don't know what your level of Python is, but what I'm trying to say, basically an object, everything in Python pretty much is an object, and an object will have some attribute, some characteristic. And all our tables are basically, will be loaded from the database as objects. So every instance will have its attributes of ensemble, variable, experiment, and realm, and whatever you. And then there will be some, potentially some methods which are actually function that you can run on them, like latest, things like that. So that's all you do, really. So you can put that. Can you see it, or is it there? Got fast. It's a little bit different from mine. So we're going to run this one. As you can see, it's pretty much immediate. Now, it doesn't take him anything to run a search because all he's doing is actually creating in the background the SQL statement that will execute later when you actually want to look into that. So I could use this, not put anything in there, and return the entire database in exactly the same amount of time. In this case, we define every single thing that define a single instance. I'd say outputs work on the first table, so it's working on the instance thing. So we got everything defined except the versions. And I can use this count function to check what I get return. Let's see. Ah, that's bizarre. Sorry, she showed the output and it's not. Okay, stunning. So it's just returning one instance, which is what I expect because I define anything that makes this particular instance unique. If I was taking out the MIP or whatever, or the ensemble, probably I will get more results than that. Right, once you got that, you can loop through the results. Okay, so basically what we get in here, we're getting every single result, which in this case is just one. We want to print some of the attributes and see what it is. Then we start using one of the function, which is the DRS tree underscore path that returns obviously the DRS tree path. And then we started looking at the children of this. So, okay, I have one instance, but I might have more than one version. And so we're using different attributes, which give us a list of all the versions. And we're gonna print different fields for the version, which you might remember from the database. So we're just trying to, and then again, we go down into files. So when I do that, it just spit me out all the information. I mean, we obviously knew already what the model and variable and things were. That's the DRS tree path. So it just builds it up for you. That's the version. The data set in that case means it's just not available. So maybe it hasn't been, doesn't have one associated. It's often the new one which have been downloaded, which have that associated. It's actually not the latest version available, and that's been checked in October. And this is where the path, this is the long one, this is the file, it's been an historical, it's just one file. And I can't remember if that was the tracking ID, probably. Then it's got another version here, which is actually the latest. That has been checked on the same day. And actually, being the latest also, you can get the dataset ID, which identified that on the ESGF system and so on. Any question about this? So that's all you really need to do a result. And then you get your path and you can do what you want. And we'll just go through a little bit more to see how we can, what we're actually doing. Let's go in a bit more in detail. We can see what result is, and what it turns out is basically a complicated thing, but to tell you that is a query. So what this thing returns, the result of the query, actually, save as a kind of statement. And what this really means, and all you have to remember, is that you can subset that even more. You can add more constraints. So you can basically build a more complex search by keep on adding onto these results. It's a query, but as you see before, when we were looping, we could still loop through it like a list. So if we get the first result, in this case, the only one, what we see is actually this instance. So it's what it's telling you here is that this object is a row of that table we instance, and it's going to have all these kind of characteristics. You don't need to know this to use it. As you see, it's just really very simple. But I'm telling you this in case an arrow pops out and you get confused. You see all these, ARCCSSive dot something else, dot something else. It's important sometimes to understand if the error comes from ARCCSSive or from the module which is underneath. So as we say, this instance has some things like there's this version. So what is showing you here is that this version is a link to all the row in the version table, which actually belong to that instance. In this case, we had two versions, as we saw before. So and the important thing that you get out of the version is obviously it's the path. So we're just splitting down in bytes what we did before. So this version is, you kind of can loop through your results in general, and then you can loop inside that for every single result through the different versions, and you get all the information as we got before. Right, then we have, as I say, we have the latest function that you can apply straight on to the instance. So this again looks slightly complicated. And this return you, which is the version. Now this is made more complicated, in fact, by the fact you can see. So this is really just an instance object. This is the function, but I'm getting the first result out. And this is because we might have more than one copy of the latest. This might seem useless, but sometimes I have people telling me, oh, can you read and load this because the files are broken? And then when I go and check all the latest, there's going to be one that works. So it's still useful to know that. Generally what I do, for example, in the script I done to facilitate the search that everybody can use, I just pick up, if you set you want the latest, I just pick up the first one that comes around. But it's good for you to know that eventually if you want to go a little bit more deep, you can find more than one. I know it's starting to get complicated, but it's not the tool, it's CMAP. Sorry about that. Sometimes can be avoided. And you have to work out how to work out that that's the latest. It's incredibly complicated for what it is. But yes. Other function you can get all the file names. In this case, it's just one. And obviously, as we saw before, you can get the DRS tree path straight on out of the instance again. In this case, for example, you'll assume that the latest is, you'll just get the first result of the latest right on for you. Right, so I'm just going to skip through that. It's everything clear at the moment? Right, so the other reason I have to say, which was a bit bad warning up there, why we don't use straight on DRS tree path is that sometime in that case is you just get one latest. So they'll pick it up a bit like the module does, but if that got the broken files, which is where people then come to me and say, you know, you don't get a second chance. You know, they just select the first one coming, the first latest. And so you can just use the, if you're more familiar with that, most people prefer to use the DRS tree path. It's kind of easier. Just use that, but just keep in mind that the database have all the others and the actual path as well in case the link is broken or similar stuff. Right, then to filter the results, SQL Alchemy, which as you said is the thing that handles all the SQL language, so that handles all the query as a filter function, so we can use that one. What we need to do, so to make it a little bit more complex thing, is to import again from the module the table definition. And this is because we're going to actually work on depending on the way the fields are defined and various things. So I'm importing all three of them, but really we're just going to run a query on the instance. And then we created just lately an extra method called unique. So you can use this one, which is just an example of other things that are there in the module, which we're not necessarily going to run through, but you might try to use. And unique basically give you back all the distinct value, for example, for all the model on your search. So it's a bit similar to that DB models we found before, but it's going to be applied just to your search result rather than everything. So we can run again search, and this time, because we didn't specify as many fields, we get 105 results, right? I guess that's because we didn't specify a model, right? And we wanna go through them. So that's an example how to use unique. I put in my search results, and then I define an ensemble, because I want to get all the distinct value of ensemble. And so now I know what I can choose from. I could do the same with a model or with an experiment with any of this field. It basically uses all the defining attributes of instance. And let's find that. And this is, we're trying to, what we're doing here instead, we're trying to use filter. That's why you need your table, because you're using these attributes, which is ensemble, and you set up being equal to a particular value. And then we're using count again to see how many results we're getting, which is 6. And then finally, just to see if that works, I just apply the unique function to the new result. And it returned me just R6 because this is what I wanted. So clear? Right, so in this case, we use the equals operator, but there are other operators we can use as well. In fact, there's tons, which are not listing all of them. So I just wanted to put another one, an example in which we're using instead like. Like basically allows you to use a wildcard. If you see here, which is the % sign. and it's going to return anything which will start with R6, I1P, and then it could be P1, 2, or whatever else. And again, we're going to do the same thing as before, and we return 8, and in this case, we return both of them. So this could be useful. I don't know if you want to do this with ensemble, but also maybe model. I think I have example in which we get the miracle model out like that, or whatever you want. Another operator. So these are all very, I mean, the kind of, don't worry too much about the, how you have to write down the command, because you can always go back and look at the example. But you can see the operator are pretty much straightforward, are the one that you use in lots of other things. And this is the same that in Python you use with in to check if something is in the list. That's just a little bit weird because you get in underscore. And then what we're doing basically here, we're doing a search, still using outputs, which does all the other bits for us. And then we have a filter, and we just want to get variables which belong both to task min and task max, which we couldn't get straight on outputs unless we did, you know, the search twice, which you can as well do that. So we get again, and we get a different number. Right, in fact, you can add as many filters if you want. You can keep on adding filters after filter after filter. And in this case, we're doing the same thing. Then we filter between in, task min, and max. And then we get all the model which had ESM in the name. We go back again. We're going to get a slightly different result. Any question? Or do someone wants to have a break and try something on their own, or do you should just go on? Right, so now we get to the point, how do I open the files? Sometimes people ask that. In reality, it's really very simple. All you need to get, your path. And I guess you need just to, it's just switching into that. The database doesn't contain the file itself, but contain enough information for you to go and find it wherever it is. So we made a simple, in this case, a simple example. We import in NumPy and netcdf4, actually MF datasets from netcdf4. So people who don't know, MF datasets can open more than one file at one time. So it's more handy in this case because sometimes although I might probably have avoided to get daily data, but for example, with daily data, you will have lots of files, and MF datasets will open all of them like a one aggregated file, so you don't have to open each one. Then I define the most silly function that I could. So this is, we just passed in the name of the variable and the path into this function, and it opens using an MF dataset. And then we we load the variable into an array, we close the file, and then we return the NumPy maximum for that particular array. So, yeah, go this. Right, so now what we're gonna do, we're gonna perform a search again, like we did before, or actually, yeah, we're using they, we put in a couple we print the count just to see that we found something. And then we call in this function to see what the maximum value for the variable is. And we pass in the input, the variable, and the variable and the path. We retrieve them from the database, and then we'll pass them on. And we do exactly as we did before. So we look for the results. We save the name of the variable so we can actually load it into an array here. And then for each version, we get the path. We could have gone straight on to the latest, but it doesn't really matter. It's just have a bit more. And then we calculate the maximum and we print it out. So it's working. Should be at some stage. So it's calculated for the first one, which is the task temperature. And let's keep on going. So it's really just about remembering that the main search outputs which you might start with will give you back an instance, and then you have to retrieve your versions from that, make a choice if you want the latest or whatever, and then use the path out of that. Once you have that, that's why I say the most important thing really is understand how the database is organized. Once you have that in your mind, then you can get the path out and use it. Obviously, to make this more more versatile, the more you get familiar with in and like and equal or different from or whatever, all this kind of thing, the more your search can become more specific and so on. So then we wrote the last bit, how to integrate in your Python script. So in that case was kind of fairly simple, if you want it, because we were just applying the same kind of function to each one of the results we were coming up with. But sometimes we might want to have, either separate searches or pass two different variables at the same time. And in the end, what you do is the same thing that you will do normally in your script. So I just wrote this thing, which is not even that well written. But what normally people ask me is like, how do I get, if I use the RS tree, I can loop through the model, and I can loop through the ensemble, and I can loop, and I know, how to build more complex functions and things doing through that. So I just show a way, which is a bit dumb in a way, to do it for this. So I define a different function, which this time gets two different variables, which will have two different paths. And I think I calculate the mean and then the difference between the mean, something like that. It's not really important. So we do a search, and we're trying to get a task mean and task max. So we have a single search here. We'll return both of them. And we can check which, for example, in this case, I've been using this function unique to get all the different values that I have potentially for model and ensemble. And if you think this is more or less what you will do, you will go into the particular experiment and thing, and then you start see which model you have for that, and then which variables you have, and if you have the variable you want, and so on, and the different ensemble. So, should return the result. It's a bit slow, sorry. It's probably due on. It's a bit hasty. All right, if that was working, which I'm not sure. What we're actually doing, so I've just been trying to reproduce what people do by using the database. It's not the best way to do it, but maybe it's the more intuitive starting with, So once we have the list of models, which I don't know, refusing to give me, for each one of the models, and then and looking through each one of the ensemble in a similar way that you will be, you would have done, going through the directory. You can just filter your results a little bit more, apply an extra filter, so you get the model which is identical to the particular one you're working with, and ensemble is identical to that, and task mean. In this case, I know for sure I'm going to get one result, so I can use something different, which is first, which is a different method, which straight on going to give me the instance. So I don't have retrieve it, and then if something has been returned for that particular model and ensemble, I can go on and call I can retrieve the path and then call the function. So does that make sense, what I'm trying to do? As I say, there are better ways to do maybe a more complex kind of search, or using different things and structure these differently, but I guess that's what we wanted to show, just how you can obtain the sort of same thing. If this hasn't returned anything, doesn't matter, it's just known, it'll just go on to the next one. I don't think this is going to work because it didn't tell me. Oh no, it did. I don't know why it didn't show the result over there, but yeah. So right, don't worry about the last bit because it makes sense if you look into the extra material. Any other question? So basically the way to look at it, instead of looping through directory, you're looping through Python objects, but it's the same, all the information is there and you can find it. You can eventually put warning. If you put this into a script and then you're using over and over, you could put warning if you expect to be a particular version, and you just want to use that particular one, you know, you could select that, or just say, no, if the version, give me the version if it's not like this, or if I don't find the result for the model one, not finding a result. And then you can still use the module and do things by hand interactively to work out what's wrong. Right. The other way we give you to use it, which is like if you don't want to do this, oh, there's one question in the chat, sorry. Okay, we had some script which are ready, and I know as well they are available. In this case, you don't need to, well, you still need to load the module to work with them, but you get them in GitHub. So this is our GitHub for ARCCSSive, and inside everything which is in here, including an example using R, which doesn't really use the module itself, but it just uses the database. I don't know R, so I'm planning to do something a little bit better. I mean, I use it, but it was so many years ago. So, but that was the start, because we realized that actually some people here in UNSW are using R, and this is all Python based. But in any case, like I'll show you, I'll take a chance as well. This is ARCCSSive training is what we're running the thing on now. Oh, I haven't put it out. There is an extra IPython notebook which actually show the extra information about all the different operators you can use and how to use them and how to do some slightly more complicated stuff. And then there are these, the one I'm describing here, this search replica, find matching variable, and compare ESGF are the actual custom script. And I have other on which I'm working, but I didn't put that. Sorry, it's just doesn't let me change tab. Yes, let's see. So I also put here how you can just download it straight on using wget. Otherwise, you can clone the entire thing as you prefer. So search replica is obviously we return a result for a search. So you use as constraint the you pass as input, say the variable, the model, and the thing. We're going to see an example now. And by default returns the latest version available, but you can actually set it up but in a way that return all the available versions. And it saves everything into a search_result file. So we'll have details about the instance and versions you found and the path. Compare ESGF basically does a similar thing because it runs a search on the local database depending on the inputs you pass, but then it performs the same search on the ESGF node. And then basically what it does, if you find results for both of them, you can decide to compare them. I'm going to add with a comparison. And it's going to check if the version are the same or not. If it doesn't have information on the version, it gets down to the checksum and other thing. It can be sometimes a little bit long depending on the response from the server and depending on which stage you decide you're happy to log out. And obviously depending, if you want all the models and surface temperature, well, yeah, you're going to get a lot of results, so it might take a little bit long, but it works. So this is basically what I actually use when someone asks me to download data for them. So I do this first, so I make sure that, I know straight on what we actually need to download, can subset that. And we're now using it in a way in which you can actually do that yourself. And then it'll spit you out, if there are new files, spit you out a list of these files and ask you, do you actually want to put a request? What will happen basically if you do that is that there is a summary files with all the information we need to download the file, which is getting created in your own directory, wherever you're running it from. And that will be copied into a directory which I access. And I will see that such and such user on this date has requested this data, and I can straight on download that. So we've been testing that with a couple of people. I think I've been using this for ages actually, and it was always working, but because there were so many problems with the nodes, I was concerned about people getting frustrated with the waiting time sometimes. But we speed it up now and we've been more confident. So that will be a speedy way because I'll check that regularly and then I can go straight on and download the stuff, and then I will know who to contact and I'll contact you. And if I have extra questions or anything to tell, I'll contact you. Yeah, so find matching variables was an attempt to do something a bit more sophisticated. So sometimes people want more than one variable. And so in this case, for example, I'll show you how I've been running. We selected RCP26 experiment just to cut it down the results, and day and amon, so 2 different MIPS. And then we select here these 4 variables. And basically what is returning here is all the models that have all of them. And next to the information with the versions we found as well. And the one thing this can't do yet is to say select the models who have all of them for both MIP, because the way we set it up at the moment. So if you see, this comes back as 2 separate results. But if there is interest in that, we can try to make this more versatile too. So for this, you don't need to know anything about Python. The way you run the script, pretty much, you like to load the module, obviously, because they load the module, but then you type Python, the name of the script, and your input arguments. You obviously don't know what they are, so all you have to remember is -h or ~help, and that will print out all the argument that it takes, what it actually does, and all of that. And mostly we're trying to be consistent between the different scripts. So it's always like E for experiment, and for model, V for variable, VE if we got version, and F frequency and all of that. TE stands for mid table. Use the M. Right, so is any question? Would you like one of these? Maybe I should run you.
So when you're running this multiple variable one, it doesn't
Yeah.
give you the directories.
No, this is just so you know which model you might want to use rather than getting everything. And then you could do a search and say, okay, I just want to do my search limiting to these models because these are the ones that have everything, rather than doing, you know, because if you just put that on the search, it will give you everything. It's kind of like if you want to put it in operators, it's like it'll give you or. So these add an extra, does the search, but then add an extra constraint and compare and check that all of them are available. So these are normally, these custom scripts are more to explore, but you know, feel free to go in there, copy the logic and whatever, and add it to your own script, which is the way to use them as well. So any question? Otherwise, if anyone is interested, I can show you how to run the compare script, so how to submit a request for data. If you like to, otherwise we don't have to, or a search. No? Yes? It's up to you. Right.
Put in a request.
Right. So just a second. Got to share again. Sorry. Okay, so I'm doing this into that way. So I'm using the VDI, by the way. This is what it looks like. So you just have to kind of install it and set it up once, and then you can open and start a new session. The session actually lasts for maybe about a week. If you don't use it, it might, for a couple of days, say, it might be terminated before. And it works like a little desktop. I think you have 8 CPUs and something like that, you know, and limited amount of memory. You have your own home. Your own home here is different from region. There is a short area that's different from region 2. But the G data, where the data is common.
So you can't access your
Pre and no. If you want to use data that you have there, you should put it on G data. But if you see this kind of, NCI doesn't want you to keep stuff on short. They want you to move it from there because short is much more limited in terms of storage. So it should be just, you know, you run your model, you drop your output there, and then you move it. But you do have G data, and so you can open a terminal by going through here, and there's some application. This was pretty much, so this is actually developed, I think, by someone in Monash or somewhere else, but then they developed for the CWS lab. So it's got this trail, UVC dot, and this type of thing. Also as MATLAB, though you had to load your own license. But it's a lot easier for people who do a lot of interactive, like I do a lot of interactive, really. And it's a pain working on Raging if you're trying to do interactive jobs. So it's much better doing it here. And now that Scott added the Conda environment, it adds a lot of modules, but you still have quite a few modules here available as well. I mean, the Conda just made it easier for people who use Python and be slow for eduron. But that's actually a good test because I'm on eduron Wi-Fi and still I can work. I run all the training through that. So that's another concern often for people, you know, because you actually open the desktop, it's going to be a bit slower than working on a Raging terminal, but unless you have a really, really bad connection, you should be fine. So you can see there's quite a lot of stuff there already. Right, so trying to think something a bit more obscure. I'll just put a model otherwise. In this case, I'm just doing a search for Tasmin, RCP26, Miracle 5, and I'm on. There it is. Oh, sorry. My bad. I didn't load the stuff in here, I loaded in here. Yes. It might just as well be in the thing which is coming up. So this is doing the search. It's going to look a lot slower now. In fact, what it was meant to do up to now is just print you out that, so you just make sure this is what you've been searching stuff, and it tells you that it found file simulation for the constraint. Is it looking at remotely first? It's more that the output is coming in slow. It normally does this fairly quickly until you actually want to access the remote stuff. But for file simulations, a bit faster. That's just the Wi-Fi. Right, so it tells you to find another file on the local database, and then it asks you if you want to proceed with a comparison or write the results. So if I say no, it's just going to write about the simulation it found. I think on the terminal system on all of them, but you want to have information on how they relate to each other. So if I proceed, it actually found it's like a nearly done on purpose, 2 new files. So he asked me, do you want to submit a request? I can say yes. And I can see what's the result. So it writes a table, which doesn't look great like that. It's better, it's written, so it's a CSV. So it's a little bit easier when you're importing on Excel or something. And basically it's telling you, okay, that's for that variable and that MIP, that kind of combination. I have this combination of the model and an ensemble. And it gives you all the different versions you have. And then it tells you that one is the latest. It's actually new. So it's something new to download. And for R2, that was the latest today. So you know that you had just one new, and then anything else, you can't find anything newer than that. And I can show you, this is basically what it would have created, a file called requests with, in this case, my user ID and the timestamp. And I just get the URL and all this kind of information that then I can use. I just have another script that created a download script from this. And you also would actually create a file with information to go into the database straight on. So normally what I do then, I download the stuff and then update the database with all these automatically creating logs, and then you can access it straight on into, if you use the database and the module. And eventually will end up in the DRS tree at some stage. At the moment, there's a bit of a change of staffing around Cyro, so it can be a bit sluggish. I think there is a cron job set up every week, but if something goes wrong with it until someone notices, the guy won't look at it because it's not his job anymore. I think someone's finally replacing him maybe from next week or the week after. And the search works similarly. So I could actually get, say, all of this. And it gives me back the path in this case. And the other thing I was going to show you is that if I put H, I get all the different options. Yeah, actually I forgot about that. I didn't when I went on holiday. I actually put something that returns also the warnings. So you can put that option, and then you will get, if a warning exists, it will appear as well. Wish I remember which warning I added now. And then you have all to say, I want all the versions. I want to know, you know, the different options. It may be you've been working with all the version and things like that. If you don't select that, then that's what you get. So if I was doing the same, you will be really lucky if there is a warning on this. Probably not. No, no warning. As I said, within the warning is a good features, but then it takes a long time to set up everything, and there's always something else coming in between them. So at least even if you don't want to use it in an interactive session or anything, at least you can use this to find your data. Any question? Right, so there's no question because it was clear, or there's no question because it wasn't interesting. Or it's very hard to get feedback, so it would be good for, it's a good chance for me. Nothing? Well, yeah. We weren't sure because then we said, oh, we're going to give a chance to the other nodes. Otherwise, it would have been a bit more interactive. But yeah, just remember about the IPython notebook. You can download that and run your. And I'll make sure I put the other one on. I thought I did, but apologies. I was organized this in a week and then went on holiday. My holiday finished this morning at 6. Kind of. And if you have an idea and you think, oh, you know, yeah, okay, good job, but, you know, I don't really need these. I need a different kind of information. Feel free to tell. We don't take it personally. We kind of had to put out something because there was nothing. We wanted to make a point, which is it's useful to learn to work with database because we potentially might not be able to download the data for you, and then you'll have to interact, say, with the database. In a way, my compare script does with the ESGF. In fact, if you're really good in Python and whatever, this automatically imports another module which is called PyESGF, which is what I use there, and you can learn to use that and add that onto your script as well. So we just want people to switch on between thinking, you know, you don't have to find all the information on the file system. In fact, there's a limited amount of information you can find there. And the good news is that, and we also want to force NCI to give us that tool for us when we had to manage a lot of data and lots of data, so it's a bit difficult doing it in that way. And that kind of work, because just before I went on holiday, we had a meeting with Ben Evans, and they were really interested in this experiment. And they're probably going to set up a proper database, and we're going to be able to actually make sure that all the, because the complicated thing now is like, is someone else going to download the data? How do I know that they adding more data? No one else is really, apart from us. But if that happens, it's a bit more complicated, but now they're going to have a tool which will go through all the file system and put on a database all the files which are data, you know, which exist on OLG data. So that's going to make a lot more easy for us to use similar tools for other data sets we have, because we don't have to worry anymore to find them out. And they were interested in integrate the database with our, so it should become a bit more powerful. And we're looking at web services, another thing, and they're potentially all going to be integrated. So we know this is not grand, and we just got it, I think, to a point in which we're happy to feel, for me, this is not completed, this is just like the start. Okay, we can show now that it works, but to make it more useful, we need to do more custom script depending on what you need, or, you know, add more example on how to do searches and stuff. By the way, maybe some other example on the docs and GitHub. People use a bit more, and feel free if you find issue to have them on the GitHub if you want, or just email us if you don't like to do that. And I show it with Python 2. It also works with Python 3. So that's about it. I think I cover everything.
I think you can save a lot of time with this tool, because you don't have to go through each model and see which variables are available.
Yeah. I mean, in the end, even if it looks like you're looping, it's actually more efficient. And as I say, there are ways in which, you know, I didn't want to overwhelm people, but if you actually just use searches and combine them, it's even more efficient because you take loops completely out of the way. Yeah, it's just a switch on how the things are organized, and we thought it was just important because you might have to use web services and they'll use similar things. And it's good to learn how to interact. Right. That's all. Thanks. Thanks, Alex.